I'm Clara. Today let's talk about, we're gonna have a supplement of the second video of the Cardano formula. Okay, so in the second video of the Cardano formula, we just talk about, there are these three roots about the x1, x2, and x3. So actually x1 is omega 1 u plus omega 0 v. Okay, so omega 0, what does that mean? So the angle is 0. Okay, so we'll prove something first. So let me tell you first what it means. Okay, what does it mean? First you're gonna have, look. First we can draw a circle, right? So the first situation is, okay, so the first one, so the angle is 0, right? So 0. And this one is 2 pi over 3 about u. So let's first draw the 2 pi over 3 slice. And the 4 pi over 3. Okay. Think about, okay, so what's the point? You can see. Okay, so first, the thing, very easy thing is about this. First, let's think about, normally we say 0 and 2 pi over 3 and 4 pi over 3. So 0, 0, and then u, we say u is less than v. So u plus v, okay, and what about this? And this is 2 pi over 3. And so you have a u, so we have the, we have the real number part and imaginary number part, and imaginary number part is like this, and v. So the imaginary part will be bigger, and we think about, okay, the imaginary number part is bigger. In this case, the imaginary number part, their sum would be negative, and in this case, it will be positive. And these two imaginary parts, their absolute value are the same, and they're just negative 1 multiple relationship, and the cosine value is the same, right? Okay, so x2 and x3 are different. So we can say a pair of complex numbers. Okay, so this is the first one we're going to talk about. Delta equals delta greater than 0. What about delta equal to 0? Delta equal to 0, and then u and v. Because actually, because then delta greater than 0 or delta equal to 0, then this whole thing was a real number to calculate. Then when you find a u and v, this is a real number. So if it's a real number, then you have actually, this is a vector, and this vector is on the real number axis. So then you'll get that's equal to modular, right? Okay, so delta equals 0, then both of them, their modular are the same, right? Because the delta part is equal to 0. Okay, so if their modular are the same, then the major part has to be cancelled. That's why we have two roots are the same and these roots are different. Or else, whatever we do, and because the modular was 0, so whatever you do, the answer is 0. So that's when the function was x1 is a real number. So the point is, we talk about that less than 0. Okay, so first let's prove something. We know that Ola said, so what said? He said something. He said e to the I theta. So e just what he wrote as an example because his name's first letter was e. So he said this like this. Okay, so e to the I theta. What does that actually mean? So that's equal to cosine theta plus I sine theta. Okay, so what we're gonna do? We have another e to the I alpha. So you go cosine alpha plus I sine alpha. So what we're going to do is to times them together. So you say, okay, so e to the I theta times e to the I alpha. So you can say that e to the I theta is actually what I write as normally a normal vector. And then whatever the modular was, and I just left. We just look about the modular was 1, and the angle was part of the angle. So this actually the alpha. First we have see the angle, and e to the I alpha we times it on. Then we have, if we times on it, then we will have what? We will let this vector. So first we have this angle theta vector. remember not theta vector. This angle is theta, and we have this vector. And we don't think about the modular when it's something else. We just set this modular as 1. Then we will rotate, if we times the ETI alpha, then we rotate this to an alpha angle. So this angle is alpha because we're already over here and moved to here, so the angle over here is alpha. Okay, so how can we actually prove it? If we're gonna prove this whole thing is equal to ETI theta, ETI bracket theta plus alpha. So let's have a look. So cosine. So this times this. So cosine theta times cosine alpha. So cosine theta times cosine alpha, you'll find some trick. Okay, so that's going to be minus because I just think about this part times this part. So I can sine -1 and this and this. Okay, so negative sine theta sine alpha. And we can put a bracket over here, and we're gonna plus. And so this part is this time this. So we're gonna I cosine theta sine alpha plus I. So this time this. So I sine theta plus times cosine alpha. Sine theta times cosine alpha. Okay, so we had this. If we had this, we had these two parts and these two parts. What do you find out? Depending the answer, we will have. Okay, you see. Okay, what is this part? Because I've actually proved when I was little, right? That about the calculus, and I've actually proved it. What about cosine? Cosine x plus y. That's equal to cosine x times cosine y minus sin x times cosine x. Times sin y. We'll have this. This is actually mapped to. You have it. Cosine theta plus alpha. Great. We got it. What about this? We can factor the I out, and then we have cosine theta sine alpha times sine theta cosine alpha. What is this? This is sine theta plus alpha. Okay, we got it. We have this. Okay, right. So what is this? We actually prove it. This is e to the I theta plus alpha. Great. We have this e to the I bracket theta plus alpha. This is how we prove it, right? So we think about, okay, so I have this. So we do. Okay, so we're gonna think about. So normally, we know. So what I think, is okay. I'm gonna think about. I'm gonna think about the u and v when delta less than 0. Actually, we know the method because in that age, they don't. The mathematician maybe they don't just think about the negative and the complex numbers, so they can use the Vietnamese method to use the cosine sign to prove the answer, right? But in this case, I'm just trying. Okay, so what's u? So u is actually equal to cube root, and then inside it is a negative q over 2, and then plus square root and q over 2. Actually, it's uppercase 2, so whatever it is, it means the same, right? So p over 3, 3, 3. Okay, so v, then this positive sign turned to negative, right? Okay, so we have this, all right, and think about okay, so this part, because delta is less than 0, so this part delta will change to, okay, to what? This whole thing will change to I times the number. So we have number plus I times the number, and this is the number minus I times the number. So the difference is this plus, this minus. Okay, so we think, okay, but the point is over here. How can we use, how can we calculate the cube? How can we calculate the cube root? This is the point. then we can change, because this is a normal complex number. So we can change this as some kind of rho times a cosine theta. This is cosine alpha 1. So if it's u, then that's rho times cosine alpha 1 plus I sin alpha 2, I sin alpha 1. And v, we can change to alpha as alpha 2. Remember the rho are the same because only a positive and negative difference, but it's how can you calculate the rho, the modular? 2 parts square and then plus them together and square root. So square, it doesn't matter, right? It even is positive and negative, so that's the point. You got it. So their modular when delta less than 0, of course, same. Okay, so we're same, and the difference word is an alpha 1, alpha 2. This is their difference. Okay, so think about so it's their difference. So let's just think about if over here, actually, you'll know that in this case, what's you going to do? Their angle, their theta, properly, if you add this angle, so v has the opposite angle properly, then this, you get this. And then draw right up this circle. Okay, so this is so these two parts, positive and negative, so they can be cancelled. So this is very, very properly lucky. It's not lucky, it's just like this. Very, very. Okay. Let's just think about it. Okay, so we can rotate this because normally we move to here. Alright, so no matter what thing. In this case, move to here, of course, they can be cancelled. But now it's not like this because the angle is gonna be greater. So the imaginary part will be less. So we're gonna let this be less, and we'll let this be less. Okay, so the start angle were less than 0, so we have less. Okay, so the angle that they were going to be less and going to be greater are the same. So you have this answer were correct. Okay, you have this positive, this negative. Okay, so the imaginary part, right? That's it. You got it, right? This part and this part, and then cosine, right, same. Okay, so this is how we think about it. Right, we're gonna think about this. Okay, so actually, it does satisfy that if you try from the calculator, you just try because you have these, the u and v, and you can find the rho, and so you can just finally find the u and v being a complex number, and you can just do what you want. It just, first you have a u angle, and actually you can find that if you find, because in the method I just, we use a complex number and the Veritas method, and if you use the Veritas method, you have a cosine, and cosine is already 103. If you don't think that 103, actually these two are the same. That's totally mapping to each other. Okay, so this is it. So this is when delta less than 0. So delta greater than 0 or equal to 0. I've already explained it. Equal to 0, their modular are the same, and one situation just it's here, and one this cancel, and another one is whatever you do because it's actually 3. So you have 0, 0, 0. You have this 0, 0, 0, this root. Okay. So delta greater than 0, as I say, this is a pair of complex number. Okay, this is one gonna,